Thank you for having me. They've made me much more important than I am. I'm not the Adjunct Director of the TU Delft as a whole, but of the Digital Ethics Center at the TU Delft, where, as Bertrand was already telling you, we work very actively on trying to approach all these different ethical questions from the philosophy, but very much in collaboration with computer scientists. So what I want to talk about today is, to some extent, philosophy, how we are looking at some specific values that we have for these trustworthy AI systems, but also very much about how we are going to be able to connect this more conceptual work to all the technical work that you are doing that's being showcased here, for example, at these poster presentations. Because I think we all share the same goal to a large extent. So we have this probably very familiar image of how machine learning systems are often being developed, and what we want is more than just stirring the pile until things start looking right. We want to actively design these systems in a way that they incorporate the values that we have for them and that they are trustworthy. Of course, we already have a whole bunch of values that we want for these AI systems. Frederik was talking about the EU values. I have them on a slide here as well. These aren't going to be complete. I mean, there will be lots and lots of specific cases where we have different values, and one of the research challenges for us from the humanities and the social sciences is to try to incorporate participatory design methods and ways of finding out which values for all the different stakeholders that will be interacting with these systems we should be designing for. But what I wanted to focus on today is more the question of, okay, how are we going to get from these values to the final design? So assuming that we have them, how can we make sure that this ends up in our systems? And we do know from experience that this is something that we can do. We've done it for lots of other technologies. To give some low-tech examples, there are these bridges in New York designed by Robert Moses at the time, and they were designed in such a way that they're high enough for cars to pass under so that they could easily access the new beach that he had just built alongside a beautiful park in New York, but they're too low for buses to pass under, which effectively meant that everyone from lower income parts of the cities were excluded from these areas of the city. So this very actively incorporated the values that he had, the kinds of people he wanted to give access, in a low-tech piece of technology. And we see this all over. So you have it for bridges, you can have it for benches, where you might have certain values about whether you want homeless people sleeping in your parks. And of course, finally, we have it for AI systems, which is where things get a lot trickier. And the way to make sure that even for these difficult systems, we can get these values in the final product, well, from the TU Delft perspective at least, is to try to make this translation from high-level values like explainability, like human oversight, the two examples that I'll be talking about today, into concrete, non-functional design requirements. So they're not going to be about the accuracy or the specific goal of the system, but they're additional requirements that we have for these systems. And we want to slowly motivate these requirements from the overall values that we have. So the rough setup that I will be presenting here is that you're going to go from very high-level abstract specifications down to more and more conceptual detail, and then finally, hopefully, you can link the specific technical tools that you're developing to these values that you want, so that it's not just we built something technically because we want to do good and because we think that this will help, but that there's a clear motivation as to why this technical tool solves the overall problem that we've set with these values that we want to include in our system. Now, that's quite a challenge. The way in which we think that can happen is really through interdisciplinary collaboration. So we do a lot of these, and they often happen in an iterative cycle. So for the whole process, which you have here on the slide, it would be both looking at, well, in this example, for the ESGs, both looking at empirical research on, okay, what values do we need, what values are important for the specific use case that we're considering, conceptual investigation, so that's the part where I and my colleagues come in to try to say, okay, how do we specify these values? How are we going to translate them into something concrete? And that's what happens very often in collaboration with the people finally building the actual tools. Prototyping, and then again, empirical analysis to see, okay, did we miss impacts on indirect stakeholders? The way, for example, Google Maps missed the impact that you have if you redirect lots of traffic through neighborhoods to avoid traffic jams on the highway. Suddenly there's a lot less road safety in these neighborhoods on the outskirts of the cities. It turns out that you also increase average traffic time, but there can be these unexpected side effects from making technical choices for this rerouting case in neighborhoods with typically lower income individuals. So you do this kind of empirical context analysis to see, okay, did we miss something? Probably we did, and then we start all over again. And really, the more feedback loops, the better. So I figured another slide with even more of these loops will only help. And then the part that I want to focus on for this afternoon is to see how we can get from these values to the functional and non-functional requirements. Now, that's the really big challenge, of course, operationalizing these values. That's not really news to you. But what I want to hopefully show here today is that we have some examples that can inspire you to do more of this work. So for some values, like privacy, we already have quite a good sense of, okay, well, there are various dimensions to privacy. You can view privacy in terms of risk mitigation so that people's private information isn't abused. You can view it in terms of autonomy so that if you have privacy, you're feeling less restricted in the choices that you make. If there's constantly someone looking over your shoulder, then you're going to be making choices differently than if you know that no one's looking. And so on. So there are different dimensions of privacy in this case, and you can link those back to, well, this dimension of privacy, we want to mitigate these specific risks for a particular application, and we can do that through technical applications. Now, the challenge is to do that for all these other values for Trustworthy AI, and the first one I picked for today, because it's something that we've had a large interdisciplinary research group on for the last couple of years, is human control over systems. And to start with a non-self-driving car example for a change, I have here a case from Uber where they do dynamic pricing. So they have an algorithm which of course determines the price that you're going to be charged for a particular ride. And most of the time that's fairly acceptable. There are some discussions going on whether this pricing is biased in certain ways. But let's assume that generally speaking this is okay. Until at some point, and this was 5 or 6 years ago by now, there was a hostage situation in Sydney. And what did they observe over at Uber? Their pricing algorithm went mad. So everyone logged into Uber at the same time to run away from this dangerous situation. And a taxi ride cost 150 euros for just a very short ride to get away out of the immediate vicinity of this hostage situation. And the same thing happened over and over again. So when there were the terrorist attacks in Paris, Uber's algorithm went mad for about an hour or so until they managed to shut it down. In London, when there were stabbings there, the same thing happened, and they haven't really managed to get this under control. So every time when there's this kind of situation, you see that it's very difficult for them, or at least that they're not incentivized enough, to actively control these systems. And so what we want, really, is to avoid this kind of thing and to ensure that the people who are using these systems are actually in control, that we have this effective oversight both for Uber but also for other AI systems. But the challenge is to figure out what that really means. And like I said, I'm a philosopher, so for me that means starting at the question of what is this concept of control? What does it mean to be in control of an autonomous system? And in this case, this wasn't my work, but it was the work of my colleagues, Filippo Santoni de Sio and Jeroen van der Hove. And they started from this theoretical specification of control. So there is a wide philosophical debate on this, and they formulated these two dimensions of what it means to be in control over a particular decision or over a particular decision-making system. First of all, that's the idea. There should be some kind of tracking of the reasons that the operators, the person who's supposed to be in control, has. So it has to be responsive to what you want and not just do its own thing regardless of your own of the intentions of the person in control. So if you wanted to stop increasing prices for people in the area, then it should stop doing that rather than just continue in the same way over and over again. And second, there should be some kind of tracing back to which person this really is supposed to be. So it's not just that there's an amorphous control somewhere. It tracks reasons, but we don't really know whose reasons are being tracked. We don't really know which person is supposed to be responsible and that person is really aware that they're supposed to be responsible. So there should be some kind of tracing back to specific people. Okay, that's the idea, but this is not something that you can just clearly build. So the next challenge was to try to make this a bit more concrete. For that, we can start to sort of slowly unpack these different definitions. So that's what we've been doing for the past couple of years, and the idea is that we can formulate at least 4 different dimensions that follow from these basic definitions. You need to have some kind of definition of which moral reasons or which reasons we think are relevant. So there should be some kind of operational design domain, but in terms of, okay, what should this system be paying attention to? For Uber, we might say, well, we want it to avoid overcharging people when they have to flee during emergencies. So that in these particular cases, there should be a ceiling to the price that's being charged. For self-driving cars, you might have a much more extensive operational design domain, and it's going to vary a lot per system what this will look like exactly. But there's a challenge of formulating which reasons are relevant. Secondly, it should do this actual tracking, and that sort of falls apart into 2 aspects. First of all, people should know when to intervene. So there should be compatible representations between the system and the operators, that they're not thinking about the situation in completely different ways. So for example, for Uber, there might be some kind of common definition of emergency. And you have to know when you are in an emergency. So there should be some kind of information available. Okay, this is when I should intervene, and here's a light that will go on in the right situations, something of the sort. So you need to have an information aspect, and then finally there should be some way to actually intervene. Now for Uber, that can be a very simple stop button that they revert back to a simple price ceiling and they charge everyone the same. Very often that's not going to be the case. So if you look at self-driving cars, the idea of, well, we'll give control back to the human driver when the automation fails very often doesn't work out very well, because the person who's behind the wheel wasn't really paying attention anymore. They take 10 to 15 seconds to notice that they should be doing something and to take control of the situation. And at that point, you've run into a truck or whatever your car was about to hit. So there it's much more challenging to formulate, okay, effectively intervening will mean some kind of shared control where you're constantly engaged in the task, because if you're suddenly given control, it won't work. It also doesn't have to be a purely technical fix. So in this case, the suggestion is it could be a stop button or it could be a particular kind of shared control for cars. But for an insurance company where they were evaluating claims over in New Zealand, the idea was that we'll give control over the outcomes by giving every decision where the AI system advises against granting the insurance claim back to a person who will do everything by hand. So there it's more, we'll grant everything automatically, but the situations where we think that someone might not be entitled to money, which was 5% or so of their total amount of insurance claims, those we'll do by hand, so we'll have clear accountability, explainability, and so on. So they might be socio-technical solutions to maintain control rather than purely technical ones. And then finally, there should be some kind of traceability, so a kind of recording function, as it were, in the system to make sure that you know where the different intentions and reasons were coming from and who was responsible finally for what happened. So that you have some kind of solution to this question of who is responsible for the outcome of the system, rather than pointing to the AI system and saying, well, we don't really know. Someone should be responsible, but we can't find out who. Okay, so that's where we are more or less with meaningful human control. This still doesn't really push you into the very concrete technical tools for specific use cases. That's something that we're still working on, and that's going to be a lot of additional effort to really bring this into practice. But I do hope that it gives a first sense of how you can slowly start to connect these values through further specification down to what we need to technically design. And likewise, I wanted to focus a little bit on explainability to give a different kind of example that we're working on between the philosophy department and the computer science department to show that this kind of thing can work for specific questions that we're working on. So for explainability, of course, there's all these discussions about which definitions to hold. We have a whole workshop this afternoon on definitions of explainability. And generally speaking, these are fairly wide-ranging. So of course, they cover a lot in terms of we want people to understand the agent's logic. We want there to be a kind of interface that makes things comprehensible. We want to have, perhaps from one of the review papers, a very specific set of information. But the question is still, what should these explanations look like? So again, as a philosopher, I'm then tending to go back to this philosophical literature where we've been discussing explanations for the last 60, 70 years or so, and there are a whole bunch of theories about what explanations should look like. So that was my first instinct to say, well, let's look at what these have to tell us. Now, the theory that I'll present here focuses on causal explanations. It doesn't cover everything that these definitions from the previous slide are intending to do. So this question of human interaction, background knowledge, and so on, interactive systems that Frederick was mentioning, they aren't really covered here, but it's more the question of what information should an explanation provide you. So how do you answer a question when someone asks, why this? And then the suggestion from the philosophical side is that the answer is always going to be a cause that led up to the effect that you're asking about. So that's quite a strong claim, but the idea really is every single explanation will take the form of a cause. And this cause will highlight, most of all, the difference between what you're asking about. Why did let's say, why did my kid drop his plate of food on the floor, compared to an alternative outcome? So that's where this interest question falls in. So there's always a kind of alternative that you have in mind. Why did you drop it on the floor rather than eat it, compared to, or why did you drop it on the floor rather than leave it on the table? And there are going to be different answers to the different questions. And finally then, what are these answers going to look like? The suggestion is that you'll have both a generalization, so some kind of covering rule that relates these changes, that will tell you, because the situation was like this, we ended up with the effect that you're interested in. And we'll have a bunch of counterfactuals, so these alternative situations that you're contrasting it against, that are covered by the same rule, and where you can show, well, if things had been different in this way, then you would have had the alternative outcome that you were asking about. This is mostly inspired from the natural sciences, so a lot of the natural science theories fit this very nicely. You'll have, let's say, Newtonian gravity, where you can change the values of the different variables, and you'll see the different outcomes drop out in terms of, well, if the value had been differently, then the outcome would have been different as well in this way. So if we sum this up, then you really have, for these philosophical accounts, these two parts. So you have a covering rule, and you have counterfactuals. It also comes with quite a nice standard for the quality of an explanation. So here too, there's quite an extensive literature on explanatory depth. And the main idea is that, well, the wider your explanation is, so the more of these alternative situations you are covering, the better the situation is, the explanation is. So explanatory depth is related back to the amount of phenomena that you can explain with the same explanation, and that's, for example, according to these theories, why general relativity is a deeper explanation of gravity than Newtonian physics, because general relativity covers a wider range correctly than Newtonian gravity does. Okay. That's quite a theoretical picture, again, to start with. So to make it a bit more concrete, I thought it would be helpful to relate it back to some of the explainability tools that we currently have, to give you a sense of what this might tell us about these explainability tools. So if we have something like feature importance, then it can fit the definition a little bit. So we might have, depending on how you're calculating this feature importance, you might have a sense of how things change in the local environment, because you've looked at different variations of the input and you've calculated how these different variations in input will lead to a change in the output. But the information that you're showing doesn't really give you a covering rule or a counterfactual. So you don't really have either of the two in the final explanation that you're providing. We do have those rules, of course, when you're doing more rule extraction-based systems, and some of these prototype trees that I saw up in the presentation slide have similar setups where you're trying to give a covering rule for why did we see this final outcome. And these are much closer to this idea of what we want to have a wide rule for why do we see these different cases. And sometimes they include counterfactuals, but most of the time they don't really have the counterfactual element. So they focus on why did I get this answer and not why did I not get this other answer. And counterfactuals do the exact opposite. So for counterfactuals, you have a lot of information on why did I not get this other answer, but you don't really have this general rule, this generalization that's being called for to get a final explanation fitting this whole framework. Okay, so that's roughly what's out there. This is a very rough and somewhat unfair summary of what's out there, of course. But the idea was that we want to move forward a little bit from this more causal definition of what explanations might be. And then we have a nice connection back to the mathematics in the form of these causal inference techniques that have been developed for different automated systems. So you can actively do causal inference. You can calculate automatically what happens when when features values change from one value to another. And this was our very first sort of prototype trying to include those causal inference methods back into the explanations. by looking at both what a model does for the actual case that you're interested in. So it might be saying, oh, well, this picture of a bathroom is actually a kitchen in the top part of the image. Well, you might be interested. Why? Well, and then you get to the answer. You say, well, there's no bathtub, but the causal inference part is by checking, in that case, also in images with bathtubs. What does this value of whether there's a bathtub or not affect? What's the effect of that on the final AI output? So the idea is to get towards a sense of what the difference is going to be between having a bathtub or not. This is very much still a prototype, so this is not the kind of explanation you can plug in now and it will work. But it highlights how you can go from, again, this idea of, well, we want to have a causal explanation. We want to have explanations that have both this covering rule and this counterfactual element. And this is the pipeline that we were using. So you go first from adding in concepts to make things more understandable to the end users, to then formulating causal graphs and actually calculating these causal strengths to be able to have both this overview and the specifics on the counterfactuals as a way to try to operationalize a philosophical account of what explanations might be. Now, at some point, maybe that means that you'll have the kind of explanations that you'll see in a lot of science. I think there are going to be a lot of challenges with actually getting this causal framework operationalized for AI systems, mostly because these are operated for very linear processes most of the time. So these are, this is a case from how you can understand what dispersants and salinity of water does to oil spills. So if you want to solve oil spills, it turns out that dispersants are very helpful, and you can calculate these causal strengths using AI methods. Whether this will also work for understanding AI systems itself is an open question because of the complexity, because of the number of variables, the nonlinearity, and so on. But it's something to work towards, and I think most of all, what I hope from these two examples I've given you is not that we all go in this direction or that you all agree with the proposals that we are making, but to show that this step from values to more concrete design requirements is something that we can do and that we can do together. So all of this work has been very interdisciplinary, and that from these theoretical frameworks, we can slowly connect it down to technical tools. Thank you.
I'm just curious about the little drawings that you had in the first part of your talk. You know, they are very conceptual. The drawings linking the situation, the I should not, etc. Are they somehow linked to the philosophy of information of Luciano Floridi, looking at the moral situation and things like that? Or is it something that you did on your own?
Yeah, no, this was somewhat separate from that, but I think a lot of these philosophical accounts are leaning in similar directions. Yeah.
Okay. Oh, many questions. So let's start with this guy there. So you need a microphone? You want my mic? Jean-Yves.
Thanks for your talk. Interesting talk. I was wondering if you are interested in searching what are the motivation for searching for explanations. You may have different causes for the same effect, and you may have different motivations for looking for explanation, and this may have some impact on the way you are producing them.
Yes, absolutely. This was the more technical side, but of course there's a big question on what do we want to have explained. To some extent, I think that's in these contrasts for the explanations. So what you want to have explained depends on what kind of contrasts you're picking. So I think for this example with the plate of food, if someone throws a plate of food on the floor and you're asking, why did you do this? Then implicitly, we have some contrast in mind. So that if someone says, oh, I was full, then you're not really happy with the answer because you were wondering, okay, yeah, but you could have just left it on the table and then your I was full would still apply, but it's not really the answer you're after. The difficult part is to identify these contrasts. So they're very implicit. In principle, they're implicit in all of our questions for explanations, but we don't really know how to get them out of there. We understand it, but a computer doesn't. So finding these contrasts is going to be quite a challenge. I think it's also the question of whether you always want these kinds of explanations really, or if you're after justifications or more other types of transparency about the procedure or the outcomes. So this is one way of saying, well, explanations of the form, why did this happen? We might want to provide those using causal frameworks. Other types of questions that are being lumped under the name of explainability or explanation might require other approaches. So yeah, I think it's a very valid point. This is just a small part of what could be an answer. And there's going to be variation both in what we're interested in for the explanations and in the goals that we have when we're asking questions.
So thank you. So I found this kind of decision tree very interesting because my sense is that that's basically what a lot of kind of decisions are being made on today. Like, I mean, you have the municipality or government making decisions. They make these really simplified decision trees in order to be able to explain their results. But it seems like they don't explain how they reached that decision tree. I mean, it's like, oh, I think it was, you denied a loan, for example. So why, I mean, I earned, what is it, I had to increase my salary $10,000, something, but why can't, I mean, maybe I can do it. So in some sense, it's like, it seems to be more about fairness. They want to have this kind of black and white decisions rather than actually explain, to have to explain the kind of individual decisions. So it seems to me that in some sense this is more to avoid having to actually explain things and to get this perception of fairness by having this kind of oversimplified in some sense decisions. So I'm curious whether you could relate maybe, I don't know, fairness and explainability, or do you, actually I think it's also related to the previous question is, what's the motivation for providing these explanations? And I think the motivation both for the person making the explanation and the person asking for the explanation will have a lot of consequence for whether this is conceived as a reasonable explanation or not.
Yeah, so I mean, and indeed there's a lot of separate research on how explanations impact our fairness perceptions. I think so the decision trees that were mentioned here, I mean, they don't quite fit in with the framework. So what I think would be the answer from the philosophy side first is that the reason that we want to have these causal explanations is so that we know how to change things. So the theory is called interventionist, and that's for a reason, because the goal that we have for explanations is to know if we want a different outcome, how can we get there? So then it's very much in line, I think, with what people who are getting a decision that they disagree with or that they don't understand want, namely, okay, but what would have made this different and what would have changed? How could I have effectively changed things? So I think that matches quite well with a lot of the motivation that we have for providing explanations of AI systems, especially from the ethics side of people getting unfair impacts and so on. Whether that's going to be feasible in terms of providing this in a simple way for very complex AI systems, that's an open question. We have managed, of course, in lots of other fields to provide clear explanations for complex systems, but not everyone is going to have the time to learn something similar to general relativity just to understand why a loan decision was made. So there too, that's a partially unfair answer to say that we can do this. So to some extent, I think your question is going to come down to, do we really want to provide explanations all the time, or is it more going to be, we want to show you how we've done this, what we've tried to make a system fair, and then offer you effective ways of contesting a decision and reasoning along with you. maybe that's what it's going to come down to. I think that's an open question for everyone working on explainability, if we can make this a reality or if we have to find a way around it. But hopefully, if we can make it simple and interventionist and so on, we don't need to.
So, I mean, I think that's a good answer, and I think it's actually, I really agree on this, that it's about what do I need to do to change something. But then I would, again, argue with this, say, the loan case. Oh, you have to have a salary above X thousand. They don't need to explain that. They just say that, oh, well, your salary is below that. So your change, I mean, what you need to do is to increase your salary. Well, that's clear, but how do they explain and motivate that particular that boundary? That's usually not explained. I think that's interesting.
No, well, I think currently we have both the rule, sort of, well, we've motivated your maximum loan amount through these legal steps. If you can borrow at most 5 times your income, and then so then you have a general rule, and then you know why your specific case falls under that limit. And then you can again ask, why is it this amount? And then we have further discussions back to politics. So I do think we have a decent chain of these different explanations. But that's not what the counterfactuals are offering you, because they don't have the general rule of why does it have to be 10,000 more in my particular case.
Well, thank you for your very interesting talk. One additional question is how close has to be the explanation to the ground truth of the system? Because somehow we have to bridge from the sub-symbolic world to the symbolic world. So there is some unsharpness, but also telling a complete different story might also not work. And so how do you measure it, and what about this gap?
Yes, I think if I'm very honest, that's a very good open research question. What I do think is that even in a lot of science, this is the case. So we very often idealize parts of our scientific theories compared to the ground truth. So it's not as if all of our scientific theories use concepts that we expect to be exactly there. Often we've even used mathematical symbols because they were convenient, and then it turns out that they are helpful and that they refer to something, but we weren't aware of that before. Still, that leaves the open question, how far can you go? And I think really the only concrete answer I can give is that the question that you can still see whether the explanation correctly predicts what the AI would output. So then the question is, okay, how many of these what-if things have been different questions for the AI system can you cover? Probably you won't be able to cover the entire system with one explanation that's both simple and understandable and so on. But maybe you can cover parts of the system accurately, and then you have to figure out where the limits of your explanation are. So that's the only concrete measure that I can give you at the moment. But it's a good question.
Just a small addition to that, because you know the three Turing prizes, Lequin, Bengio, and Hinton, they wrote a paper about that for the Turing prizes, and they say they are the deep learning specialists, and they say we have the symbolic grounding in our systems because we are directly taking the data and we build our internal symbols in our networks. So they say we have the symbolic grounding, but in fact somehow it's true, but what can you do with this symbolic grounding then afterwards and build in order to build explanation? That's the really big open question. We could discuss this forever, but I know that you also want to have lunch. So, and visit the exhibition. I remind you that we talked about explanation, the explainability village is right there. We talked about the specifications, and you go to the end-to-end, which is at the end, logically speaking. And I propose that we get together back at 2 o'clock, and then we will start looking at the outcomes of the Confiance.ai project. So 2 o'clock sharp. Thank you, and have a good lunch.